Any question from the lecture video you watched or from the homework problems? Anything I can answer first. Any question?
Professor, I have a quick question.
Yeah.
From the lecture video, when it was talking about the modulus, so the modulus is another version of division, right?
Yes, modulus is
Okay.
another operator. Just like
Because I saw it and I got a little bit confused by it, but then I eventually realized it's just a shorter way of saying division or another way of saying division.
yes. So you're still confused about that?
No, I got it now. I just want to clarify that.
Okay. Yeah, let me quickly go over the modulus operator. It can be confusing because all other operators are there in the math, and this is the only one that's completely new, and it's designed only for the programming purposes. So let me quickly explain that for everybody. Modulus. Okay, the modulus operator has this percentage symbol, same as percentage symbol. So just like writing A plus B and A slash B, you can write A modulus B. You apply the modulus operator to A and B. So the meaning of this operator is, the result of this operator is the remainder of dividing A by B. So for example, if I write 15 modulus 4, then you divide 15 by 4. 4 goes into 15 3 times, and there is a 3 remainder, right? 4 times 3 is only 12, so remainder is 3. That 3 is the value of this operation, remainder. So 7 modulus 3. 3 goes into 7 2 times with a remainder of 1. So the 1 is the answer there. So this is an operator that produces a number which is actually a remainder of dividing first number by the second. And it is the reason for this operator is it's in computer programming, it's a valuable tool. For example, if you need to figure out whether a number is odd or even, then you can apply the modulus operator to that number. If the number is odd, like the 7, then your remainder will be 1. If the number is a even number, like 8, I'm sorry, not, that's a bad example. Number is 7, and if you take modulus with 2 to determine whether it's even or not, you take modulus with 2, and if the number is odd, like 7, you get a remainder of 1. If the number is 8, then 8 modulus 2 will be 0. So if the remainder is 0, if the modulus operator produces a 0, that means the number is even. If the modulus operator produces 1, then the number is odd. So that's one example. And the modulus operator is useful in a variety of different places. And that's why it's there. And it's the only operator that's in computer programming, but not in math. That's why it may be confusing to some of you. Any question related to that modulus operator? All right. Any other question?
I have one more question.
Sure.
I got a little confused with the cast operators.
Okay, I can explain
because
that.
Okay, no problem. Because one of the examples, it was saying how here 3/2 is 1, and it would be converted to 1.0 because it's a floating type. But in the example, when I calculate, I didn't get like 1. I got 1.5. So I was confused about that.
Yeah, okay. Let me explain cast operators. Cast operators are the keywords int with parentheses around. That's called a cast operator to convert to int. Float with the parentheses around is a cast operator to convert anything to float. And similarly, char is a operator that will convert to char. So, so let me give you an example. int x equal to 65. Now you learned the decimal codes. Every letter in English has a ASCII code, and that ASCII code is also a binary code of another number, and that number is called the decimal code of that number. And the decimal code of A is 65. Letter capital A is same as 65. So when you store letter A in the memory, or when you store 65 in the memory will have the same thing, the same code, same ones and zeros will be there. So therefore, the computer system doesn't know the difference between A and 65. So it's the programmer who has to know what you are storing. So if you store A or 65, the memory looks the same. So if I store 65 in the memory, I have this. And so now suppose that I print the X, then I'll get 65 printed, right? So suppose that you don't want to print the 65, you want to print the equivalent letter, which is A, then you can say cout char parentheses X. That means convert the value of X to char and print. And now you're going to get A printed. That's just a simple example of the operator, cast operator.
Professor?
Yeah.
I have a question.
Yeah.
But what if you put a char, like a char, lowercase x equals A, then wouldn't that be, then can you just negate the char, the parentheses char x, or no, capital A, so it would be 65.
Okay.
Would that
If you do that, then you're storing character A. You have to have quotes around it.
Yeah.
You're storing character A in X, and that's equivalent to storing 65. Yes.
That also count as 65?
Oh, then it's character. Yeah. So
Okay.
now if you just print it, cout X, that'll print A, because you are storing character and you're keeping it as a character. So yes.
It's just about the statement before you print it on the screen.
Yeah, here we are storing 65. You're not storing a character, and you know, in the program we may have a reason for storing 65 in X instead of character A. But when we print it, if you want to print the equivalent character, then you use this operator. Just as an example of what you're doing. You stored 65 as a number. You needed that for some other purposes, and you stored it as a number. Now you want to print it in the character form, then you just temporarily convert it. It just it's only converting just here. It's for the printing purposes, it's converting, and the value of X is still 65. Okay, just for the purpose of printing, you're converting. That's when the cast operator is useful, just to convert for the purpose you have. So to give you another example, you learned that in the last lecture video, you learned that if you have arithmetic expressions, then like this, int A equal to 7, B equal to 2, and you want these numbers to be those integers. And if you write any operation, A plus B, as long as both are of the same type, the answer will be of that type. So here A and B are both integers, so the result of this will be integer. And if one of them is a decimal number, like 2.5, then this has to be declared as float. And if you have that, let me redo that. Float B equal to 2.5 and int A equal to 7. And then if you do declare a float type variable S for the answer, and you say S equal to A plus B, the answer that's coming out of this operation is going to be float now, because one of them is int. A is int, B is float. And when that happens, the system is instructed to convert both of them to the larger type. The larger type here is float. So therefore, this A will be converted to have 7 points. And this already has 2.5. And after that, it'll be adding them. So it'll convert them when you're doing the operation. Only if one of them is different from the other. I mean, two operands are of different type, then it'll convert. If they're of the same type, it's going to give you, it's not going to convert anything. It'll give you the answer of the same type. So that's the rule you learned in arithmetic operations. So with that rule, if I'm doing division, I have a serious problem. So let me give you an example. Int x equal to 7, y equal to 2, and float z is a float type variable, and then I write z equal to x over y. I don't, I have 7 and 2 stored, so I do this x over y and print z. Okay, can anybody answer this question? What will be printed? You have to show exactly what will be printed.
A float type variable.
I'm sorry? X and Y have 7 and 2.
It will be floating
Dividing.
point.
Say again?
Z will be floating point, right?
Z is floating point type. Yes. The correct answer of the division would be 3.5, right? Are we going to get
Yes.
that? Are we going to get 3.5 printed here? Anybody? No, we are not going to get 3.5. What are we going to get? Can anybody tell me?
3.
We're gonna get 3.
3 is not exactly right.
Okay.
Would it be 0.5?
No.
3.0.
3.0 is correct. On the screen, you will get a 3.0 or 3 point printed. Sometimes it's system dependent. Some systems don't print the decimal point when there is nothing behind it. But the answer, your correct answer for the question here is 3 point. You must include the point, otherwise it's wrong answer. In computer arithmetic is slightly different from arithmetic you learned in your kindergarten. Here, the decimal point makes a huge difference in calculating the numbers. So therefore, in computer arithmetic, when the number is a floating point number, the decimal point must be there. Otherwise, it's wrong answer. So if you write 3.0, that would be better because, the reason for writing the 0 behind the decimal point is the decimal point can be missed by the eye. So if you put a 0 behind it, you won't miss it. Anyway, the answer is 3.0. So if this is a combo question, 3.0 is the right answer. If you write 3, that's the wrong answer. So let me explain why, for those who don't see it. The x and y are both integers, and therefore, when you divide x over y, you're dividing 7 by 2. When they're both integers, the answer will be integer, which means it will only give you a 3 as answer, the integer part of the actual answer. That's all you're going to get from that. So this division will produce a 3. And then when you assign it to z, since z is a float type, it'll become 3 point. So z will have 3 point. And that's why you're getting 3.0. The correct answer is 3.5. You're not going to get that. So when in a situation like this, I have reason to have 7 and 2 stored in integer variables. And I don't want to change that. I don't want to change that in to float. We are talking about a long program where these numbers need to be integers. Okay, so what if I want to print the correct answer for this division without changing the original declaration? I don't want to change the original declaration because I need to have those variables hold integer number. So let me erase this and show you how to do that, how to make it print the correct answer. Without changing the original declaration, I just want to get the right answer for this division. So the division here is just an intermediate thing in your program. And that's not the only thing. You know, you're going to do other things with the X and Y, so you don't want to change the declaration. So how do I get this printed correctly? Here's Z equal to float X divided by Y. Now you're going to get the right answer. Why? Because I'm converting the X to float temporarily, and then temporarily for this division, for the purpose of this division, and then dividing by Y. So now I'm going to divide 7.0 by 2. When you're dividing floating point number by an integer, it will convert both to float. So the actual division will be 7.0 divided by 2.0, and that will be 3.5. So therefore, if you now print the Z, it will print the correct answer, 3.5. So that's what the cast operator is for, just to do the conversion, just for the purpose of making this particular statement work. You don't want to change the int declaration here, but you want to get the right answer for the division. So you temporarily change the type right there, type of that value. But the X remains integer, just the value of X is converted to float right there. So I hope now you understand the purpose of the cast operators. That was Neil asked the question, right? You understand, Neil?
Yeah, I understand now. So if it was switched now, if it was, let's say, float was X, wait, if it was float and then integer was Z, the 3.5 would become a 3, right?
3.5 will be, oh, you mean here, when I print the Z, you mean?
Yeah, if
Yeah,
you
if I-
switched up the float and the integer.
If I, yeah, instead of saying C out Z, if I put cast operator int Z, then I'll be printing 3,
Okay, no problem.
right? So the cast operator can be thrown in whenever you want to convert temporarily. Okay, so that's that question. Anything else? Any other topic that I need to explain?
Like, I would like for us to go over the example 2.3.19 because I'm still not understanding that.
2.3.19
Yes, on the textbook.
on the textbook. Okay, let me. You said it's an example. Okay, 2.3.19.
Specifically the E part.
Okay. Yes, I see the example. I can bring it up on the PowerPoint. All right, there's the PowerPoint. And let's go to that example. Okay. Yeah, this is the one. I mean, it has a different number on the book, 2.3.19, but it is same as this. This example 15 is the exact same problem. All right, so let me explain what happens here. K, L, M are all integers, D and E are float, and K has a 7, L is 3.5, and D equal to K over L. So in this division, K is 7 and L is 3.5. So they are, one of them is integer, the other one is float. So it's going to convert both of them to float. So you'll be dividing 7.0 by 3.5, which will produce 2.333. So the D has 2.333. All right, so let me write that on the board. D has 2.3333. And now going on to next line, E equal to float K over L. Float K means converting the value of K to float, which is making it 7.5, and then dividing by 3.5. So still it's going to be the same answer. Converting K to float doesn't change anything. Already, you know, only one of them need to be float to get the right answer. And in the previous line, D equal to K over L, L is float. So therefore it produced the right answer. In E, you're converting K to float. L is already float. So that now both are floats. Still it's the same answer. So E is also going to have 2.3333. Now going over to M, M is equal to K divided by float L. So K divided by float L means converting L to float. Oh, wait, I'm sorry. I didn't realize L is declared as int. Sorry about that. So this is all wrong. All wrong. Going back over. K, L, M are all integers. D and E are float. And K is L 7, L is 3.5, but L is going to be 3. Why? Because L is integer. It cannot hold 3.5. So K has a 7. So K has a 7, L has a 3. And yeah, and then going on to the division, D equal to K over L, D equal to K over L. So now the K is integer and L is integer. K is a 7, L is a 3. They're both integers. So you're dividing integer by integer. So you only get integer part of the answer, which is going to be 2. So D has a 2. Let me write that as a memory cell. D has 2. And next line is E equal to float K over L. And that means you're converting the K to float. 7 point will be divided by 3 now. So 7 point divided by 3 means you're going to get the correct answer because they both will be converted to float and the answer will be float. So therefore, E is going to have 2.3333. And next line says M equal to K over float L. So now you're converting the L to float, and only one of them need to be float to get the right answer. So this is also going to produce right answer, which is going to be 2.333. So M has, oh no, the answer of this division is 2.333, but you're assigning it to an integer variable. So M will only pick up the integer part of that, which is 2. Even though division is going right, you're only storing integer part of it in M because M is integer. So now you're printing D and then E and then M with the space in between. Now remember, if the problem asks you to write the output exactly as it will appear on the screen, then you should write exactly as it will appear on the screen, nothing else. So output will be exactly what this Cout will be printing. Cout D space E space M. So that'll be 2, and then a space, and then 2.333, and then a space, and then another 2. The value of M is also 2. So that's how you show the output. I've seen students writing output saying D equal to 2, L equal to 2.333. I mean E equal to 2.33, M equal to 2. No, that's wrong. Because this D equal to and E equal to will not print. This is all that's going to print. Only show what will print on the screen, exactly as it will appear. If they're going to appear on 2 separate lines, then you had to show them in 2 separate lines. Remember that when you're doing your homework. Okay, so is that clear now, Gina?
Oh yeah, I see what you did for the
Uh,
division.
Okay, anything else? Feel free to ask anything that you didn't understand. Okay, then I'll move on to our exercises. All right, so I have here the first set of questions are to write the exact output that you expect to see on the screen as a result of executing these statements as part of complete programs. They're not complete programs, but you can make complete program out of them and run them. So if you make complete program and run, exactly what you will expect to see is the question. All right. Can somebody tell the answer for part A?
It would be Z
Uh,
because 90 is character Z, right?
90Z, so the uppercase Z. So your answer will be is you have to tell me exactly what will be on the screen. So you're saying a Z will be on the screen. Is that all?
Yeah, Z on the first line and then 90 on the second line.
Okay. 1 second. Okay, so Neil's answer is, if this is the screen, there will be a Z first, and then on another line, there'll be 90. Is that what you meant, Neil?
Yes.
Okay. Everybody agree with that? Any question? Okay, that is correct answer. S1 will have a Z, the 90 will be converted to char because S1 is char type. So it'll be Z, but S2 has 90. So you will get Z and 90. So it says, what is the output? That's the question here, right? Output. Then right there, you would write a Z and a 90 underneath it, and that's your answer. So remember that if this is a homework question or test question, that's how you present the answer. Exactly what you expect to see on the screen. That's all you write. Okay, part B, anybody? the alphabet uppercase Y has decimal code equal to 89. The decimal codes are given at the top, right here. The decimal codes are given. That's because you need them to answer some of the questions here. And if it is also in the, when you're doing the homework, you should look up the decimal codes when you need it. If it is a test question, the decimal codes will be given to you. You don't have to memorize them. All right, anybody has answer for part B?
Would it be Y89 on the next line?
Y and 89?
Yeah. Or
No, we are only printing one thing here.
also 89, wouldn't it?
89, yes.
Yeah.
Right. Okay, very good. So the answer for part B is 89. Oh, number C.
Three point zero.
Any other answer?
.5.
Okay, any other answer?
0.5.
Okay, I have three answers. Anybody else?
Never mind, I retract it. I put 1 instead of 7.
Okay. Okay, 3.5 is correct. Now remember, when you're doing problems like this, you have to pay attention to every little detail there. The V1 is declared as float, and then you're assigning 7 to it, so only 7.0 will be stored in V1. And M1 has a 2. Now, when you're dividing 7.0 by 2. That's going to produce 3.5, right? One of them is float, means you get the right answer. And then you had to look at AND. Is that int or float? That's float. So therefore, 3.5 will be stored as 3.5. And so the output will be 3.5. That's how you determine that. You have the division, you had to look at operands, and then the assignment is another thing. Division is first, and then the assignment happening. When the assignment happens, again, conversion can happen. So you have to pay attention to all that.
So if there was a cast operator there, that would be 3.0.
Right. You can
Okay.
you can use cast operator to make it 3. Okay, going over to D. Problem D.
I got 24.0.
24.0 is correct. And everybody can see it, or anybody needs explanation? Okay, let me explain anyway. N1 is integer, so it's only going to take 24. So N1 will be 24. And then when you assign that N1, a copy of N1 to N2, 24 point will be stored in N2 because that N2 is float. So it will be 24 point. Now remember, if you write 24 as answer, that's wrong. So remember that for your homework and test. The point is a big deal in programming because it makes the difference between getting correct answer and wrong answer, as you will see later. All right, going over to E.
Lowercase b.
Lowercase b is correct. Okay, quickly explaining, 98 will be converted to character when you're storing it in chart type variable. 98 converted to character is lowercase b, and that's what you're going to print. Okay, part F, anybody?
Would it
67.
be oh, okay.
Okay, there were two answers. What are they again?
I was gonna say
67.
67.
Okay. One student says 67. Any other answer?
Yeah, I got 67 as well.
Okay, 67 is correct. Okay, for anybody who doesn't see it, character C is being stored, but in an integer type variable. So it'll be converted to integer, which will be 67. And when you print it, it'll be 67. Part G.
Would that be 7?
7 is right. Dividing 47 by 8, 8 goes into 47 5 times with the 7 remainder. 8 times 5 is 40, so remainder is 7. So that 7 is what you're printing. Okay, part H.
$3.5. I'm not sure about
Okay,
that.
I have one answer, 3.5. Anyone else? $3.5 is wrong.
3.0.
Okay, 3.0. Any other answer? Okay, 3.0 is correct. Can everybody see it, or anybody needs explanation? All right, let me explain anyway. 7 over 2 is supposed to be 3.5, but you're not going to get that because this M and N are both integer types. They're declared as integer, so they both hold integer type value. So you're dividing 7 by 2, that will only produce integer part of the answer, which is 3. 3 is the result of this division. When you assign it to float type variable W, it'll become 3 points. So W has 3 points. And so when you print it, you're going to print 3.0. 3.0 will be correct, but I strongly advise you to write 3.0 when you mean to write decimal number, because I don't want to get into an argument with anybody about whether there's a decimal point or not. Okay, it's hard to see when you don't highlight it with a 0. All right, part I.
The 4.5.
Okay, I have an answer, 4.5. Anybody else?
Is it 4?
4.5.
Sorry, I didn't hear that. Montaran?
Oh, I said, is it 4?
4.
I
Just
got 4.5.
okay, 4 and 4.5. I have 2 answers. Anybody else? Both are wrong.
Is it 4.0?
4.0 is correct. Okay, let me explain. The 9 divided by 2 is going to be 4, right? I explained already. Integer divided by integer will be integer. So you're not going to get the 4.5 from that division. That's a 4. And when you assign it to float type variable, it'll become 4 point. So 4 point will be printed. Okay, so but I recommend writing it as 4.0. All right, going over to problem 2. Now here it's these are C++ expressions, and so the result is what it's asking for. And whenever the result is a floating point number, you should have decimal point behind it. So it's the same thing that we did, but here we are not using any variables. It's written as if it's an expression. So you need to find the value of these expressions. Part A, anybody?
5.5.
Okay, any other answer?
5.5.
Any other answer? I just explained in this previous question, 9/2 is not,
Oh, it's 5.0 because yeah.
Yeah, 5.
not even 5.0,
5.0. No, 5. Wouldn't it be 5? You said it was an integer.
just 5.
Yeah.
Integer divided by integer will be integer. There will be no decimal. Okay, part B.
Will it be 4?
Okay, I have 4 as answer. Anyone else?
I got 5.0.
Okay, 2 answers. Anybody else? I'm only getting 2 students participating, maybe 3, but the others are quiet. No other answer? Okay. 5.0 is correct. Okay, so there is an additional thing to pay attention to here. Order of operations. There's a multiplication and a division. And you learned that multiplication and division belong to the same level of precedence in the list of order of precedence. The system has a order of precedence in which parentheses will be first, and after that, multiplication and division will be done. If there are more than one of those, it will go from left to right. And only after that, it will do the addition and subtraction. So those are the orders. So the multiplication will be done first here because there's a multiplication and division, and therefore it will go from left to right. The left one is the multiplication. So when you multiply 2.0 by 5, that'll be 10.0. That 10.0 is divided by 2. When you do this arithmetic, you always, if it is a decimal number, you keep that point. Only then you'll be doing it right. This is a decimal number, 10.0. So use it as 10.0. When you divide by 2, it'll be 5.0. Decimal number, 5.0. Okay, part C. Anybody?
Professor,
Yeah.
you said, I remember that you said integer with integer gives an integer product.
Right.
Does that rule apply with float? So if a float number divided by float will give you a float?
Yes, actually float number divided by integer will be also float.
But never a int,
Right.
never an integer.
Right, because float is the larger type. So if there is a float operand and an int operand, it'll convert both of them to float and carry out the operation.
So if I would, if it would say float first, then integer, on the statement, would it become an integer?
No,
Like,
it'll be
No, if there are 2 operands, let's say X and Y are 2 operands in your operation, whatever the operation is. Okay, X and Y, no matter what the operator in between is. If they are both integers, the result will be integer. If either one is float, the result will be float. Okay, it'll convert both operands to float and then carry out the operation. So it doesn't matter whether it's a addition or a division, regardless of the operation, that's the rule. If they are both of the same type, your answer will be of the same type. If they are different type, then convert to larger type. Larger type between float and int is float. And so float is the largest, int is next largest, and char is the lowest, the order. So it'll always convert to the larger one. So I can even write, yeah, maybe I should do that. A in quotes plus 1. See out. Okay, think about this example. This is valid. I can add a 1 to the character A. Guess what will print?
$65 plus 1.
So what is going to print? Is it going to be a number or a character? You know, you had to decide that. Okay, nobody can see that? All right, let me explain. So this is a char type, and you are adding that to int type. When there's no
Wouldn't be a
decimal point,
number.
that's integer. So when you add a char type value to int type value, both of them will be converted to int. Int is larger than char. So you are going to get 65 here and a 1 here added up. And the result is 66. So it'll print 66, not the letter B, because the result is int type.
Okay, I get it. Thank you.
All right. Yeah. You have to pay attention to the data type, and in any operation, the data type is going to get converted, and pay attention to that. So now, see if you can
Excuse
do
me, Professor.
Yeah. go ahead.
Just one more question, just
Yeah.
to make it clear. So when you say bigger, like integer is bigger than character, you
Yeah.
mean by the memory space it's
Yes.
taking up?
Yes.
Okay.
The bigger means the bigger one is the one that gets more memory.
Okay, and the biggest one would be float, correct?
Float is the biggest one.
Okay, thank you.
Mhm. Even though between float and int, you both get 4 bytes of memory. Between them, float is declared to be largest by, you know, whoever designed the language. So float is the largest, int is second largest, char is the smallest. Can somebody answer part C now?
Okay, so I don't know if I did it correct, but I got 4.0.
4.0. Okay. Yeah. Let's hear the other students. Any other answer?
I got 4.0 as well.
Okay.
I got 4.0.
Okay, very good. 4.0 is correct. Anybody needs explanation? Well, let me explain anyway. The 5/2 is in parentheses. So that operation is going to be done first. Remember, parentheses is always first. So it'll divide 5/2, and that will be a 2, not 2.5. So that 2 multiplied by 2.0 will be 4.0, because one of them is float, so the answer will be float. Okay, part D.
I have a question for the parentheses, not for that, this for the percentage is it's dividing, right? Is that what it means?
It's called modulus,
Yeah.
and it means remainder of dividing. Yes,
Remaining of the
remainder of. So I have a division, I have a slash, then I have a modulus.
Would that be infinite because you can't divide by 0?
I'm not dividing by
Because
0. Oh, you? Okay, I see what you're doing.
yeah,
What you're doing is wrong.
so do I have to do the 53/9 first and then the modulus 3?
Right.
Oh, okay.
Division is first because, yeah, the order of precedence says multiplication, division, and modulus all belong to the same level. And if there are more than one of them, you'll do left to right. Okay, that's the rule. So there are more than one of those three operators here. The division and modulus are there. So it's going to do left to right. Okay, can you figure out the answer?
I think it's 1, Professor.
I got 2.0.
Uh, 2.0 is wrong. Any other answer?
I got 2.
2 is correct. All right, let me explain that. The 53 divided by 9 will be done first. And when you divide 53 by 9, the answer is 5. Answer is 5, not a fractional number, because integer divided by integer is going to be integer part of the answer. So 5 is the answer there. So the next step is 5 modulus 3. 5 modulus 3 is 2. 3 goes into 5 one time with the remainder of 2. All right, let's do the part E.
Would it be 6?
6 is wrong.
Would it be 2.0?
2.0 is wrong.
Would it just be 2?
2 is right. Okay, let me explain. 17 modulus 6 means remainder of dividing 17 by 6. 6 goes into 17 2 times with the remainder of 5. So the value of this operation is 5. Now you're dividing 5 by 2. 5 is integer, 2 is integer, so the result will be an integer, which is integer part of the division, which is 2. 5 over 2 is 2. Okay, number 3 says A has 7, it's declared as int. A, B, C are declared as int, and they have 7, 5, and 2. And what will be the values of the following C++ expressions is the question. You have to pay attention to the order of operation to get the right results. Okay, part A, anybody?
Would it be 6?
6 is wrong. I see what you're doing, and that's wrong.
Oh no, division is first.
Right.
Would it be 9.0? No, wait, 9. It would be 9. Sorry.
9 is correct. Okay, let me explain. B over C will be done first because division is supposed to be done before addition subtraction. So it'll be 5 over 2, and the result of that is 2. And that'll be added to 7 to get 9. They're all integers, there will be no decimal point. Okay, part B.
3.
3 is right. because A over B is 7 over 5. 7 over 5 will be 1. When you add it to 2, it'll be 3. Okay, part C.
Zero.
No, wrong.
Would it be 20?
20 is right. I think I know what the other student did. You did the multiplication first. That's wrong. The addition is first, and then the division. Only after that, the multiplication. The addition first because there's parentheses. So A plus C will be 9. 9 will be divided by 2. Between division and multiplication, the division is going to be first because it's on the left. So A plus C 9 divided by 2 is 4. You're multiplying by B. 4 times 5 is 20. So 20 is the answer. Okay, write this expression in C++. You're short on time, so I'm going to ask you to tell me the answer. Anybody has an answer, go ahead and tell me. How to write this in C++.
Would it be X
Okay,
times parentheses Y times Y?
we don't need that parentheses
Okay.
because when you have
Division.
two multiplication, it doesn't matter which order you do it, right?
Okay.
Okay,
Division
division.
5 times S.
Okay, anybody has a comment about that? Is this correct?
I would just put the parentheses.
Yeah, you have to
on
put
Y and
parentheses.
Y.
Around what?
Y times Y.
Around this?
Yes.
No, you have to put
They have to put
parentheses
around the whole
the
expression,
whole thing.
X and Y.
Parentheses around the,
6 and Y, and then 5 and S.
okay. So you mean right parentheses including the X? Include X in the parentheses?
Yes.
Okay, so parentheses X times Y, and then 5 times S. And did you say put parentheses around that also?
Yeah.
Yes, that is correct. You need parentheses around all of them. You don't need parentheses around Y times Y because when you have two multiplications, it doesn't matter which multiplication is done first. X times Y, if you do that first and then multiply by Y, the answer is the same as doing Y times Y first. So that parentheses is not necessary. But if you don't write parentheses and if you simply write X times Y divided by 5 times S like that, then you're only multiplying you're multiplying X times Y, but dividing by only 5. So if you don't put the parentheses for the numerator, it's still correct because you're going to do these 3 multiplications first. Then you'll be dividing by 5. And then the result will be multiplied by S. That's completely wrong. You want to divide by 5S. So therefore, this parentheses is necessary. The parentheses for the numerator is not necessary. But if you put parentheses in the numerator and write it as this, that's not wrong. So having more parentheses is not wrong. It'll make it look complicated. Other than that, it's not wrong. Okay, part B. So both of these are correct answers for this. Now we're doing part B.
Parentheses Z times.
Are you doing
part B. Yeah.
Okay.
Oh no, 2. My bad, Mike.
Okay. You need 2 outside. right?
Times A plus B.
Is this correct, the way it is?
Shouldn't it have like a multiplication sign between the two in the
Yes.
parentheses?
You need multiplication symbol, right? And,
Division
uh-huh,
A minus B in parentheses.
right, okay. That's right. You don't need another set of parentheses for the numerator because the multiplication, the addition will be done first and then the multiplication will be done. So the numerator will be done first. So you don't need additional parentheses. Then the A minus B will divide that. So that is correct. And now we are on number 5. It says write C++ statements to replace the float type memory cell W. So that when the question says something like that, that means W has been already declared as float and it has a value stored in it. Okay, according to the problem, there's a value, a decimal number, fractional number, and you need to write statement that'll replace the value with the whole number part. So here's an example. If W has 21.34 in it, then you should replace, your statements will replace it with 21.0. Okay, the fractional part should be dropped. So you're only writing statement to achieve that. Okay. The name of the variable is W. So how do I do that? Anyone?
Would it be float full value equals 21.34 as the first line?
No. Okay, you are making the same mistake I expected. The 21.34 is used as an example to illustrate. We don't know the value of W. W has some value. We don't know what it is. Okay. We are not working with any number. W has a number and we need to replace it with the whole number part of it. No one has an answer. You need to write one statement that will replace W with the whole number part of it.
W equal, no.
Yeah, you're going to replace W with something else. So therefore you do need W equal to something, yes.
And then W times whole num.
What do you mean whole num? The word whole num? No, there's no such thing.
So would it be W times W?
W times W means you're squaring the value of W and replacing W with it. You're replacing the value of W with the square of the original value. But that's not what you need. Okay, I'll give you a hint. You need to pick up the integer part. Integer part, the whole number part is the integer part, isn't it?
What if we do W equals parenthesis int parenthesis W?
Oh, okay. W equal to parentheses int W. Is that what you said?
Yes.
Yes, very good. That is one way of doing it. Because what this does is it will convert W to int. So when you convert W to int, you're losing the fractional part altogether. And if the number in W is 21.34, now you have a 21. This is 21. And then when you assign it to W, it'll become 21.0 because W is float. And that is one way. But there are other ways. Anybody recognizes any other way? You know, when it comes to computer programming, there is not one way to do things. There are more than one way. So that's why each one of your program is expected to be different from the others. All right, so this is one way to do it. Another way is to declare another integer type variable x and assign w to it. Now x has integer part of it. And then you assign x to w equal to x. So that will store only the integer part, and it will become, it will get a point added, so, because w is float. So you can take two steps like that or one step like that. And they're both correct. Okay, I hope you learned the techniques and ideas. You know, the programming is all about ideas and techniques, and that's why, you know, it can get to be sometimes difficult because, you know, you had to come up with the idea.